In this lecture, we're going to investigate the linearity and time invariance of a recursive system like this. This is also sometimes called an infinite impulse response filter. This system is recursive because the output of the system, y of n, is fed back into the system with a time delay. In order to determine the output of the system y of n, we need to define a boundary condition. In this case, the boundary condition will be that the input signal x of n will be zero valued for all negative values of n. We will also require that the output signal y of n is zero at negative infinity. Okay, let's start evaluating the output for certain values. We start with minus negative 1. At negative 1, the output is 0 due to the boundary condition. At 0, the output is just the value of the input times constant beta. The next value of the output at y1 is alpha times beta times x naught times beta times x1. So we're going to keep iterating this output signal and hopefully you'll see a pattern emerge. Okay, and now for an arbitrary value of n, the output is going to be a sum over k from 0 to n, alpha to the power of k times beta times x, input signal at time instant n minus k. Okay, so that's going to be the closed form solution for this recursive system. Using this closed form solution, now we can test for linearity, and here is the test of linearity. So the left hand side, basically the linear combination of outputs fed by signals x1 and x2 multiplied with coefficients c1 and c2. Using this closed form solution, evaluate to this. Okay, and now the right hand side, the system fed with the linear combination of inputs. Again, using the closed form solution, we can see that the left hand side and the right hand side are equal, which means that this system is linear. Okay, let's look at time invariance. Here's the formal test for time invariance. It should not matter in which order we apply a time shift to the input signal x. We should be able to feed the input signal x of t into a delay and then into the system, or into the system t and then to a delay. y1 should be equal to y2 for this system to be time invariant. Okay, let's evaluate the innermost system. So on the left hand side, we've evaluated the time shift. So the input signal x becomes x time shifted by tau. On the right hand side, we get the closed form solution for the recursive system. Okay, on the left hand side, let's start looking at the output values of this system that's fed by a time shifted input x. So the first value where the output is non-zero is going to be at minus tau, because n plus tau should be 0. So minus tau plus tau is 0. So then the output is equal to beta times the input signal at time 0. The input signal is 0 valued before x naught. We're going to evaluate the output of this recursive system just like we did without the time shifted input. And we can see hopefully that a pattern emerges, and it's the same pattern that we saw before, except that we have a time shift. Okay, and the last step for the left hand side is to do a variable substitution. So we're going to substitute minus tau plus n with n prime. So So we're just going to make a new index, n prime. So therefore n will be n prime plus tau, and therefore the closed form solution is going to be this. Okay, on the right hand side, I'm just going to remind you that D, the system D, is a time shift, which will just modify every instance of n and replace it with n plus tau. So we're going to apply the time shift operator on the right hand side, replacing every instance of n with n plus tau in the closed form solution. Okay, and we can see the left hand side and the right hand side is the same equation. This means that the system is time invariant. So this recursive system is both linear and time invariant.